All right, welcome back, and let's get started. Thanks for joining me again on this great cold Friday evening. I really appreciate you hanging out with me on Twitch. Uh, Glad to see the viewers that are here. You made it through so far, the horrible ice and snowstorm that we had. I know up here in Ohio, we're still digging ourselves out. Fortunately, though, managed to get the driveway opened up. So get the car in and out as I need to, which is perfect. There's a lot of effort and a lot of work, but hey, it's been a while since we've had heavy snowfalls like this. Managed to get my 10-year-old snowblower working again. The poor Frankenstein, looking into getting an electric one maybe for next year. A really beefy one, going to be definitely doing the reviews and seeing what's out there. But hey, got the snowblower up and running again. That made life much easier. So I really appreciate you hanging out. I know the weather's pretty tough out there, but at least those that are here, and I feel bad for anybody who's still without power or anything right now. Haven't really heard too much, but I know there's still some areas that are still struggling, digging themselves out of this mess. But I'm glad you're here, and glad to see you're safe. So in the last video, we pretty much tidied up all the additional test points and some of the schematic changes and PCB layout changes we wanted to make to the board. Like adding the small 104 filter cap for the temp sense line, adding a bunch of those test points, adding the big ground pores for the switching regulators. That way, their heat can be pulled away more efficiently into the board. So it looks like we've got all that done. Again, I'm not really going to push immediately to get the spin ordered, the new stencils and new boards, because I want to make sure, try as best as I can to make sure we don't need anything else added or changed or modified before we go ahead and do that. That way we get it all done now. These, again, are the perfect times to catch mistakes, make additions and changes before we order parts. Because we still have some real estate on the board if we really wanted to throw anything else on here. Bottom, definitely a lot of place and a lot of open spot on the top. Go to the primary display. So yeah, we have a whole bunch of real estate here. We have some spot up here a little bit, over here, and definitely on the underside if we really wanted to add components. If we really absolutely had to add more GPIOs, we could always do something like a port expander, like an I2C port expander, and just kind of offload a couple of basic GPIOs off of here and throw them on the port expander. But I don't see any real need for that. So far, everything's looking fine. Sorry, I had to mute myself. I yawned. It's been a busy day. Had to run some errands and get a lot done for work. Technically, if we really wanted to, the boot right here could be a GPIO input we could use for something, and it could be. You're just, since it's pulled up, you'd be looking for a low. It's only it's pulled up because it's for bootstrapping. Let's go over here. That would be right here, boot mode. Yeah, that's to ensure enter. When you use that and the bootstrapping, the enable and stuff, that it do everything so it boots up into bootloader mode or basically load from internal memory mode. So yeah, you could use that for GPIO once you're bootstrapped. You're just looking for like a button press, but you're looking for a low. So it could be done, and who knows, we might use it down the road. So I'm not, or at this point in time, I'm not terribly worried about GPIOs or anything on this board, on this design. So with that in mind, we also received the, let me get my phone going here with the, camera because I want to just kind of share a few little things. So I tested the PET-G to use it as light pipes. Unfortunately, it's just not conductive enough. It just does not conduct light well enough to use it for light pipes, and it's a shame. So, and it's fine. I kind of expected as much. It's not really good for that, especially at the kind of distance. 20 some millimeters thick basically is quite a distance. So I've got some actual pull this over. So I got some actual light pipes coming in. I ordered them. They'll be delayed, but when they come in, I'll make the changes to the lid because these are round. Plop them in, and we'll test them out, see how they work. But these are actual light pipes for this purpose. Like basically just like a nice, really clear piece of acrylic that really is good at transmitting light. So I'm hoping is that this works. Then it's going to increase the BOM a little bit, but at quantity, like 1,000-piece quantity, is just at the end of the day, it's just going to be a better product. So I think I'll sell 2 different versions of this. Basically, the PCB only, and then like the deluxe version that might have the case with it. The PCB and like the fan, and then the case, and then the deluxe version that'll be like with the case, all the standoffs and everything. That way we can have 2 separate price structures. Maybe even sell the case separately and all the hardware for it as like a little kit that you can get to assemble it yourself later down the road. Everything will be pretty much done, but again, all the 3D printed plastic files are there. So if you have a printer, you could always print the case assembly yourself and just supply the hardware, because it's all M3 based parts. The nylon standoffs came in. So let me get this going. Let me just show you what it looks like. I'm actually very happy with these. So they came out really nice. They're really nice and stable, nice and sturdy. They fit really well in here, nice and straight. The lid just bolts right down, no question, no problems, no issues at all. So I think I'm just gonna go and stick with the nylon ones. Nice little button actuator. That trick actually worked. They're just high enough that you could get them, but they're not too high where you're going to constantly be snagging or pushing them. Especially the enable, the reset right here. Yeah, it's a shame, but when I get the light pipes in, I'll make sure everything's lined up properly over the LEDs, and then we'll kind of redesign the openings for the light pipes, print out a new lid. I might just do that off camera because that'll be quick, and hopefully we're moved along. But we'll see, because it is part of the process. So then, yeah, the bag of extra nylon standoffs. Yeah, not too bad. I'm happy with them. And then once we get further along, we'll definitely have to adjust Odo and everything else. Put in entries for the case, because probably make another level, or just put it all part of the assembly level. We'll probably have to create like a bill of material for the case parts and all that. Make that maybe an assembly that gets pulled into the assembly level for this. We'll see. That's the great thing about using a system like Odo's. We'll be able to incorporate all that and divide all this out, have different, for lack of a better term, SKUs for the different levels of this product. So that's what we'll do with that when the time comes. But right now it's not really the time, because we've got to go through all the engineering phase, the design phase, the test this, test that, see what works, what doesn't work. Because I'll definitely want the case so we can push it through its paces and make sure it doesn't overheat while it's in the case, while it's driving that stepper motor. Because that's another thing we've got to do, is build the test fixture. and get development on that. But I'm trying to catch up on a bunch of other little stuff. Who knows, maybe because I really like to push this thing through its paces. At least continuously driving a stepper motor back and forth. So we might actually start working on the that test rig. There's just so much to do. So much to do. And it's really hard to kind of structure these any kind of stream schedule around that or video schedule around that, because I did order a bunch of materials for building that test fixture. I've got some more extruded aluminum that came in. I got more brackets, more hardware. I've got a motor mount designed for the stepper motor. That way we can, mount it to the extruded aluminum. A bunch of different things. And I'm going to tear apart another project I started working on to get the extruded aluminum from it. I even picked up a small gantry that should do the job, that we can use to just basically send back and forth down the rail, and with the limit switch. So it'll probably take us maybe designing limit switch mounting brackets, getting all that wired up and tied into the system, and figuring all that out. So it's going to be loads of fun. It's going to be very interesting, and we have a lot of little things that need to be taken care of. So just more stuff to look forward to that we're going to have to do. But I'm kind of slowing it down a little bit, because I don't want to get too far ahead and overlook some of the administrative stuff. That's another reason I want to wait to try to do Spin 2, is till we do more in-depth testing with version 1 to see if there's anything else. Maybe we need to increase the ground pour right here underneath this guy. We could. Maybe we can just go ahead and do that while we're ahead of the game. Do it before we even order a new board. Maybe we will. Or if we see something like, hey, you know what? I wanted a test point here, or I could have used a test point there or something. Just some basic things. So I want to make sure that we get all our bases covered before we get a Spin 2 out. Maybe we'll see other things we would like to do with the board. So one of the things I'd like to do for catch up is I was mentioning something about the other 2 schematic sheets. So let's see if I remember how to do this, because I've had to do this. Let's see here. Hierarchical sheet. So this is going to be so I need to bring up this guy. Only because actually I don't need to. So it's going to be T1012202501 dash this point index. Oh, all right. So that'll be this guy. All right. So yeah, some other things is I thought about, trying to take KiCad a little bit more further along. Maybe trying to do more, like see if we can create if there's a way to be able to have parameters that we can just enter and have everything get populated on the sheets. Maybe a better title block, maybe a better looking sheet. But to be honest, I don't know if I probably will not use KiCad beyond this particular video series. Just because I prefer Circuit Studio and Ultium Designer. KiCad's great. I'm not going to bash it. It's a good software package for what it does and for how accessible it is. But it's just not within my typical workflow. Some things are just a little bit more contrite about it. And I just like the Ultium products better. I'm just going to come out and say it. KiCad does what it does really well. I'm not going to argue that point. So table, text boxes. Table might be kind of cool. Oh, so that's kind of cool. So contents. Okay. TP1. Stuff. All right. So it looks like. Okay. Maybe. Oh, maybe I forgot to do that. Just kind of see how this looks. Oh, all right. Okay. Okay. All right. May have to look see what that looks like when it's printed, but hey. All right. I wonder if can we. Properties. All right. Okay. Test point and function. All right. All right. So it looks like maybe it's a little too big, but I don't know. I mean, we're seeing on the screen, but this is technically, a piece of letter, so it might print out bigger than this. We'll have to see, but I kind of like the table function of this. So that's the only problem. Is I'd have to ping pong back and forth. What I could do is come over here, open the PCB editor, drag it to my other window, and just go find the test points there. And then just enter them here. Looks like we can change that. Oh, maybe edit table. Oh, okay. GP1. It's 3.3 volts. GP2. Okay. Because we'll also have to go through and build up another bomb and everything. Oh, why are you? Oh, I see. I see. All right. Yep. Okay. So, what? 33. It's 34. I think 34. Jesus Christ! 34 test points. 34 test points. All right. Oops. All right. So let's kind of. All right. Default font. All right. Let's try something here. Wonder if we can just delete those. Delete rows. Okay. All right. What if we can... What if we... So let's see if we can make these guys. 75 mils. Yeah, see... Thought maybe we could make them all easier. Tables are nice. Honestly. The table's nice, don't get me wrong, but I don't want the... Because each has its own... Start with there. Yeah, because we can go like 100 mils here. Border, let's go 5 mils. Yeah, I kind of like this better. Because then what we can do is just make them bigger and just kind of... See what that looks like. Okay. Yeah. A little bit more difficult to set up and work with, but in some regards, but the table was a little bit of a pain in the rear too. Yeah. Yeah, so we'll see how that looks here. All right. Two, 3, DP4, 45 RX. TP5, 45 direction. Number 6, 45 TX. The ground. Yeah, this is probably going to be a very boring video while we go through this. Yeah. Yeah, I kind of like the way that looks a little bit better. And can we... Oh, we actually... Ah, Okay, so it stands out a little bit better. Okay, okay. So it's just finding the other TPs. The other test points. All right, 8, 9. TP8 is ESP RX PX 10. It's good once we find them. They're generally grouped together. All right. Limit 1. Thirteen is another ground. Let's control its input. 1. 16, and then another ground. All right. Now it's fine. 18. Actually, we're kind of jamming through these a little faster than I thought we would, to be honest. 18 is RTS. 19 is DTR. TP20 is boot mode. Now, boot mode, so 21. EN. Let's see here. Just kind of. Okay. So with the copy and paste, we can put another one of these boxes right here and still have plenty of room. Perfect, perfect, perfect. I'm liking it. Okay, we're on 22. Okay. USB DP. Data negative. 54. VBus. Another ground. Okay, all right. Cool, cool, cool. Filling that out nicely. Okay, 26. Actually, we are jamming through this pretty quickly. I'm glad. It's 57 STP. So I know the actual signals have the underscore. We might go in and change that. Let's see how that looks. Sometimes it looks like a mess in something like this. No, I think we can do that. Let's just go ahead and fix this while we're here. Try not to make it too busy, but at the same time, it's not really the actual signal name. Basically the bus name. It didn't take long to fix. Okay, TP 28. All right, that is step reset. Now that might be. Might be able to cram another one in there. Yeah. 29. Step direction. All right. All right. See. Go through and TP 30. 30. Step. 31. Okay. All right. So I think, okay, the border, we could have done that too. All right. We could even do it without, not even have a border. You know, let's see how that looks without a border. Yeah, I think that's perfectly fine without a border. Yeah. So the one thing about a table, it would have been kind of a little bit nicer and easier to see, but that works. Like I said, it's well, like I said before. Oh, wait a minute, I'm missing a couple. 33. There's 34, 36. So where is 34? Oh, there it is. Ah. STP bolt. And then there's a couple we're missing. 35 and 36. Fantastic. And PWM. All right. Yep. So the whole reason for this index is so, you know, you have one sheet to refer to without having to flip between the schematic sheets just to figure out what a test point number, what it equates to. That way you know what signal you're looking at each individual test point. It just makes life a lot easier than trying to say, okay, test point 1, which sheet are you on? Okay, you're over here. Test point 10, okay, what sheet are you on? Yeah, it saves a lot of time. It just tells you exactly what you're looking at. And based on the signal, you can almost kind of tell, you know, what circuit you're in, what sheet you would be on. So 45 direction, you know that's going to be the RS45 stuff. Anything with a step, you definitely know it's going to be the stepper driver. So it's another reason for it. It just makes life a lot easier in the long run. So now the other thing I want to throw on here is this. Again, not that we ever intend on having a million change log. Change log. All right. Okay. But we do have changes. A table, if we can get it to function and look good, I would like to have okay. Width. So revision. Let's see here. Sheet. ECN. Here. And description. All right. Let's take a look, see what this looks like. All right. So all margins are fine. Okay. Okay. That's not what I'm looking for. Row lines, width. Yeah, I don't like that at all. Again, it's just kind of not that easy to work with. Oh. So we're going to do it with Xboxes. Rev 100. We're going to have to play a border. Black. Black. All right. Okay. Not going to be the easiest, but okay. Sheet. Engineer. CN. Oop. That's a longer number. And description. Okay. So no. Oop. All right. Okay. So Okay. Oh yeah, so one of the things I did too is updated the budget for the resistor box and then the light pipes I just ordered. I almost forgot to mention that. Something's just going on. Go here. We're gonna need these numbers. So close that. Not probably the best way of doing things, but you know what? It works. So basically Rev 1. See how this looks here. Alright, so let's go to 75 mils. It'll all work out in the end. I promise. Not available. And not available. Initial. Initial design. Okay. So let's give me Rev 2. Can't spell my own damn name. Jeez Louise. Oh, I forgot to change that to 75 mils. So the big one here is going to be that. Making a data sheet? No, making a change log. That way, we'll have a quick reference of what we did to the design without having to refer to the ECRs and ECNs. That way, they just stay with the schematics, and they're a lot easier. So, to my YouTube viewers, you hear me just randomly answer questions. I'm just responding to Twitch viewers, their questions. So, ECN. So, copy this number because that's technically what you're doing all this under. That's a long number. Get a little bit more room just in case we need it. Not the best way to do things, but once we get rolling. So let's see what those ECNs are. So that is 111. Where's the 17? That is a 26. All right. All right. Yeah, this way is just a real quick, much easier way to look at the what's been changed, what's been done. I gotta figure out that one file open. Where's the 11? Oh, I see. I didn't name it properly. All right. So, didn't name it, but that's actually ECN. So the sheet that would have affected would have been the ESP32 had been sheet 3. And we got multiple sheets in here to make it easier, like 3, comma, whatever. Okay. Oh. Okay, let's see how that fits in there. Okay, that's fine. It doesn't have to be a super detailed description, just a brief synopsis of what we did. Because obviously we're going to run out of sheet here. So what we're going to do is, that does seem to work. Let's get rid of this garbage. All right. All right. Okay. So that is that ECN 111, which is technically the first one that we did. 11126. No, wait a minute. That was not that one, was it? What was this one? Oh, no. I got those confused. No. That was, no, the first one. Oh, my goodness. I'm getting my own stuff confused. 11126. Let's get these guys populated. I think that make life a little bit easier. 17 and okay. Get myself confused here. The good thing is once we get caught up, any changes in the future will be okay. So the 100 nanofarad cap. All right, what was that one? That was 117. Okay, so that was that one. That was 117. Okay, let's close that one. 111 is that was the one that we had to replace the USB UART bridge. And that would definitely be sheet 7, sheet 7. Because if you're doing proper version control, you'll have copies of the prior version schematic available. And that's what we actually have in here. Projects, stepper controller, hardware. So this would be like O2, where all the O2 parts are going to be. Basically revision 02, revision 01. So all the BOM and all the schematics are in there. So if you refer back to the prior schematic, you have some reference to what was done. So this ECR ECN, that was the heavy duty one. So I close this guy. Okay, yeah. So let's see here. 3, comma. Let's see what I got. 8. I don't have 9, how about 10? How bad does that look? I say it doesn't look too terribly bad. Many changes. Orange. Outward. Outward. And fours. Sure. See what that looks like. Okay. Okay. So what we could do if we really wanted to is now there's no ECRE and ECN for adding the test point index and the changelog, but we're not going to drive this off of that. Those are more like convenience features. So I'm not going to worry about drafting an ECN for that. Because obviously the changelog stuff I should have had for the get-go, and same thing with the test point index. I think this will just be helpful in the long run. I like the way that looks. Yeah. I don't know why it just drove me nuts seeing they weren't pushed out in a uniform manner. Although I think they're too far over now. I'm letting my I swear I don't have OCD or anything. There we go. For some reason, sometimes when I see things like that, it just bugs me, and I don't know why. All right, so that's the test point index. That's the changelog actually added, referring to the ECNs. And then that way, you have a quick reference. You know what ECNs. So when you see a revision, like, hey, we're on board revision 2, why? Because that actually does kind of come up. So let's copy this. All right. So I think we got plenty of test points on these guys. Plenty of test points. I don't see any ones I want to add immediately. All right. There. Pretty much all our signals are grabbed now by test points. 45 is grabbed by test points. All our limit switch and control inputs. The USB UART even has test points on it now. Stepper driver. I think pretty much every, even the fault. Yep, that's got a, yeah. Yep. I don't see anything, any other touch points we want to add. So I think we're looking pretty good there. Got this here. Won't need to worry about that in the future. So the PCB is looking good. Yeah. Everything's looking doable here. So, like I said, we're going to start working on some of the other stuff. We'll probably start working on the test fixture tomorrow for the TPU belt, and to actually have something to run this on. We'll just be working on throwing the firmware together. So we're going to be doing a lot together for this. We'll start sussing out and flushing out all the firmware that the unit's going to ship with. Basically the out-of-box configuration of firmware. We'll start sussing out all the things like the fan driver, get all the actual debug UART written up, start working on the 485 stuff written up, get all that stuff, get them integrated and playing nicely together. Because I know we have to make sure we're on different like UART devices, get all that set up. Sorry. We'll suss out everything for the temperature sensor. Actually write the driver, the source, basically we're going to have source and header files for all this. And work on getting them all integrated together. That way you can contact them, get information through the debug header or the RS-45. Because what I want to still do is set it up, run a cable from my office to my workshop to run my RS-45 connection, and be able to kind of monitor this off of my workshop computer, or my office computer, just because I can, and I think that'd be kind of cool. And to kind of showcase, the advantages of RS-45. So we'll see. We'll see what we can do. We're not going to do anything fancy with it. It's just going to be basically just a sophisticated UART port. I'm not going to do anything overly complex with it. That would require like super drivers and me having some more sophisticated software on my workstation computer or my office computer just to try to communicate to it. Because we could try, developing Modbus and all that. And I'm not going to for this. It's like I said, it's a dev kit. The foundations will be there for you to work with, in the device, all open source. You'll be able to plug and chug your own firmware into it and get it to do what you want it to do. And that's the main goal. And use it however you want to use it in your projects. And just have access to be able to use that stepper driver, the 8825, because I like the IC. It works out really well. It's performed really well for what I need it for. There are plenty of other ones on the market, but I really like that one. And that's why I'm doing this. So, like I said, that's probably what we'll start working on tomorrow. I'm going to have to see if I can find my TPU belt or work on getting a new one printed up so we can have it for a sizing reference. and then we'll see what we can do. We may end up having to build 2 of these. I don't know, because we're probably going to put like a store-bought, like a actual GT timing belt, one that you buy off Amazon that you would use on a 3D printer, and run the 2 side by side, and see how long they last. I don't know. I'd have to buy some additional parts to do that, but we'll see what we have to do in the long run. And I don't want to ramble, so I feel like that's what I'm doing. It's been a long, busy day. So I thank you for checking out the video, hanging out with me tonight in the Twitch stream. We a long road ahead of us. I'm hoping that we can get these boards ordered maybe next week or something. But again, I want to suss out any more potential problems, see how the light pipes work. We may want to go with brighter, bigger LEDs. I think these are 0603. We can upgrade their size to 0805. If we have to do that, I'd like to, make sure I don't have to do that prior to any of this. So we'll see. We'll see what we have to do. Like I said, those light pipes should be coming in. Everything's delayed because of the weather. So they're going to be shipped ground 3 to 5 days. So hopefully sometime next week we can start working with them and kind of see. And also that'll get us closer to finalizing the enclosure for now. I'm liking the way it came out, the way it's looking so far. I am going to probably be ordering some ABS, maybe even nylon, to try printing out the enclosure, just to see how it looks, how it takes the heat set inserts and all that. Just to see how it feels. Because also we have to consider heat, the environment it might be operating in, and ABS and nylon will perform better in those regards. And plus, I just want to play with nylon, see how my printer handles it and stuff. But I'll dig up my TPU, work on printing a new belt, and get all that stuff set up, and we can start playing around with this probably tomorrow. All right. Thanks. Have a good rest of your evening, and catch you in tomorrow's stream video.